Let's look at some class examples from 7.2a. This is on the disk method. So this is the back page of the notes. So example 1, find the volume of the solid formed by rotating the graph y equals square root of x around the x-axis between x equals 0 and x equals 4. So we first want to find where our shaded region is. So we have our square root of x graph. We have we have the x-axis, x equals 0 and x equals 4. Okay. And we're rotating this about the x-axis. So I have a dashed line here representing the center of this object, and I have a symbol here just to indicate that we're going to be rotating this shaded region around this line. So rotating all the way around, and so it'll have it's going to come down to around here, and it's going to have a kind of a bowl-shaped figure that opens to the side. Okay. Next, we want to draw our radius. So we always start on the axis of revolution, and we're going to draw to the curve. Okay. We see that these are vertical radius, so we're going to use this method, the top minus bottom vertical radius formula. So we represent radius with uppercase R, so R of x. Because we're using this formula here, everything will be in terms of x. So R of x is equal to top minus bottom. So we find the top of this rectangle, and we see what that top of the rectangle is hitting, and it is touching the square root of x. So that is going to be the top function. My bottom function is going to be wherever the bottom of this radius is touching. So in this case, it's touching the y equals 0 line. So I'll write this here, y equals 0. So that will be the bottom function. So square root of x minus 0 is square root of x. So that is my radius. Okay. So the formula is pi big R squared dx from a to b. So r of x we know is square root of x, so we just plug that in. Make sure that when you plug in your r of x that you are remembering to square it. Right? We need this area component for circles if we want to create the volume of these circular disks. Okay. And our bounds are from 0 to 4. That's we can see from the graph here. This is the furthest left the graph will go, and the furthest right is 4. And everything's in terms of x. Okay. So we have pi big R squared, and we can simplify that to be pi x dx, because the square root and the square will cancel out. Go through Powell rule, so x squared over 2. Evaluate between your upper and lower bound. Plug your upper bound in first, so 16 over 2 minus 0 is 8. And we don't want to forget this pi is part of the formula for area of a circle, so we have to include pi in our final answer as well. Will provide us the volume of our region, so cubic units, 8 pi cubic units. All right, example 2. Find the volume of a revolution of y equals 1/2 x revolved about the y-axis between the lines y equals 0 and y equals 4. So y equals 1/2 x, this is going to be a linear function, so we can graph that line here. The y-axis, okay, y equals 0 and y equals 4. So we see that this will be in the, another specification is that this is for the region that is in the first quadrant. Okay, in the first quadrant. So we're talking about this shaded region here. Axis of revolution is the y-axis, so I put a dotted line on the y-axis and put a symbol here to indicate that this is the center of this object, and we're rotating all the way around the circular manner, and so the graph will come out to here if we were to look at it once everything's been rotated. Okay. Now we're going to draw a rectangle, draw a radius. So we always start on the axis. Okay. Radius has to include the center, so we start at the center and we draw to the graph. Okay. We draw to the graph, or to the graph of our shaded region. we see that we drew a horizontal rectangle, so this will be using a right minus left method. Everything's in terms of y, so we're going to use the second formula at the top of the page here. So pi big RY squared dy from y sub 1 to y sub 2, from our lower bound to our upper bound. Okay. So here's our formula. We see that we want to find big R. So once we draw our radius, we want to identify, we're using the right minus left method. So we look at the right endpoint of the rectangle and we see where that graph is, where that radius is, endpoint is hitting. The endpoint is hitting the graph y equals 1/2 x. And the left endpoint is hitting x equals 0, so that will be the left graph. However, we do have to make some adjustments because we're doing this in terms of right minus left. Everything has to be in terms of y. So we have to adjust our equation. So y is equal to 1/2 x. If I solve for x, x is equal to 2y. So this is going to be what we plug into our formula. So right graph is 2y. Left graph is 0, x equals 0. So right is here and the left is over here. So 2y minus 0 is 2y. That's our radius. Plug this in our formula. So big R of y squared will be 2y, quantity squared, from 0 to 4, because 0 is the lowest y value and 4 is the highest y value. Remember, everything has to be in terms of y, so even our bounds have to be in terms of y. So imagine you're stacking these horizontal cylindrical discs from 0 all the way up to 4. Okay. So once we're here, we can just go through the rules that we know. Power rule, we can expand. This becomes 4y squared. Go through power rule, we get 4y cubed over 3. Plug in the upper bound first. Plug in 4. Then plug in 0. So we get 256 over 3 minus 0. And so our volume is 256 over 3 pi. Don't forget that pi. That's going to be part of our formula. So we have to include that in our answer. 256 over 3 pi cubic units. Okay, one more example here. Find example 3. Find the volume of a solid created by y equals 2 minus x squared revolved around the line y equals 1. So 2 minus x squared is a parabola that opens down. And we're going to be revolving around the line y is equal to 1. So here's y equals 1. And we see, because of that line, we have and the graph, we have a shaded region that we're going to be using. I drew the axis in red with a symbol here to indicate that's going to be the center. And if you can imagine what this object will turn out to be, it will turn out to be kind of an egg-shaped figure, kind of an oval egg-shaped figure, where it's going to go down to about here. Okay? And then this is irrelevant. These are just part of the original graph that I drew, but it's not part of the bounded region. And so we start on the axis and we draw to the curve, and we're using vertical radius. So because of that, we know everything will be in terms of x. We're going to do top minus bottom. So big R is top minus bottom. So we look at the top of the rectangle, top of the radius, which is hitting the 2 minus x squared. So that's my top function. My bottom function is going to be wherever the bottom of this radius is hitting, which is y equals 1. So then we have 2 minus x squared minus 1. Simplifies to be 1 minus x squared. Okay. We also need to find intersections or our bounds because the problem does not provide that for us. So our bounds, we have to figure out where these 2 points are. Okay, because this is the furthest left the graph goes, and this point is the furthest right the graph goes, or of the shaded region. So we need to set the parabola equation equal to this line y equals 1. Okay, if we set these functions equal to each other, we can find these intersection points, which will also be our bounds. So 2 minus x squared, set it equal to y equals 1. So then we solve for x, we get x squared equals 1, x equals plus or minus 1. So now we're ready to plug into our volume formula, pi r squared, my radius is 1 minus x squared, quantity squared, that's part of the formula, right? Pi r squared. Our bounds from -1 to +1, our lowest left x value. Okay, go from our left x value to our right endpoint. And then we can actually plug in our calculator here using Math 9 FN integral. And so we should get 16 over 15. And we don't want to forget the pi, so 16 over 15 pi cubic units.